Hi, I'm Junzhen from National University of Singapore. So I have two questions actually. So the first one is that I'm curious, when you perform the provenance analysis or causal analysis in your systems, will you encounter some dependencies proving problem? Like, for example, because I'm doing research in the OS level provenance graphs, and when we traverse the graphs, we will get the dependencies proving.
Yes, sure. You mean, for example, capturing dependencies that are irrelevant to the detected incident, right?
Yes, maybe, for example, one node can have multiple inputs and outputs, and we do not know the fine-grained provenance.
Yes, sure. We also have this problem, but we try to remove some of these irrelevant dependencies through our pruning mechanism that I was showing. So we reduce this kind of like dependency explosion, as they call it, and having those irrelevant nodes and edges to the incidents. So, but our pruning mechanism reduces those. Improves that problem. So it makes it better.
Okay, thanks. The second question is that in this work, if I understand correctly, you seems like want to abstract high-level behaviors from low-level information flows, right? So, and using frequency. Mm-hmm. And in your future, you mentioned something about you using learning approaches. So previously, I think there is a paper called Watson, and it tries to abstract high-level behaviors and then cluster them. So how do you think the improvement or the advantage or disadvantage of using these learning algorithms to do the clustering compared with the frequency-based approaches?
Okay, some of the abstraction techniques that I know about, I'm not sure whether we're referring to the same thing, but some of the abstraction techniques, although even they use learning mechanism, but at some point in their mechanism, they need domain knowledge. For example, let's say to know that this subgraph is about, let's say, program compilation. So they need that domain knowledge to know where this subgraph ends. They need that. But with our approach, because we're using that inherent cross-level dependencies that we have for different abstractions of the same resource, then we can use that existing higher level semantics. It's already there in the NFT stack. So we don't need to know that, okay, this behavior is about program compilation, because we already have that, let's say, create VNF at the top, which naturally corresponds to those operations at the lower level that are affecting the VM that corresponds to the same VNF. Could I answer your question?
Yes. So basically, you mean that you already get the ground truth for the high level, for example, summaries, right?
Yes, because we have those already existing cross-level dependencies. So we don't need that domain knowledge for knowing what this subgraph at the lower level is about. It is already there. That's okay. They are about create VNF, because this VNF and this VM are corresponding to each other.
Okay, thanks.
Accurate.
All right, we do have 1 minute, so I have a question. I think this is a really cool work because you actually conducted a user study. I'm curious, have you, other than asking user questions about the different aspects of the tool, have you tried to let user to perform a root cause analysis and compare the performance with and without the tool?
We showed them the for example, the provenance graph without applying our different modules and after applying our modules. So yes, they tried see without or with our approach, which is easier for them to identify the root cause.